forces that biologists typically invoke. So let's start this video. This is one you can find on YouTube. It's called Inner Life of the Cell, and I'm going to talk you through it. So this is the story of a white blood cell that stops an infection by going through the wall of an artery. What you see coming up is a lipid raft. That's what it is. It is made of special phospholipids that pack tightly and hold together the membrane protein specifically linked to it. Okay. These lipid rafts move around in a phospholipid bilayer. We're now zooming down one of the microvilli, a protrusion of the cellular membrane, so it's a bump on the membrane. Okay, we're now zooming down one of those. And here, coming up, we see the polymerization of actin from actin monomers. Actin filaments form the cytoskeletal network, so they give shape to the cell. And here we see gelsolin, which is an actin-binding protein that regulates actin filament assembly and disassembly. Here we've got a microtubule assembling, and here it's disassembling. This is called catastrophe. Here we've got a motor molecule called kinesin that's basically pulling a parcel. You can think of this as a UPS delivery truck with UPS labels on it. Down there you've got the centrosome and the centrioles. And all these microtubules are connecting to it. Here you've got messenger RNA coming out of the nuclear pore complex, coming together, and now a ribosome is reading that and turning it into a protein. And here you've got another ribosome that is going onto I think that was the endoplasmic reticulum. Here's another protein that's being secreted into, I think, that endoplasmic reticulum. And here again, you've got the motor molecule. I mean, I think these are just fascinating. They're basically on monorails delivering parcels. I mean, I think we have this sense that the cell, we've got all these blobs that are just floating around. Instead, everything is very tightly choreographed. Here, there are some proteins that are being secreted outside the cell membrane. Here you've got, these are intracellular adhesive molecules that are going to be binding. This is between the intracellular membrane. And remember, what's happening here is you've got an infection that's coming, and the white blood cell, this one, is going to now change its shape so it can get past a wound, past a place where there's an invasion, and so it can get at an infection and deal with it. Okay, so whenever I see this video, I see it as a worshipful act, because here you've got technology on a level beyond anything that humans have ever come up with. In fact, we have to be engineers to understand this, and we see a level of engineering that was there from the start. It's not that we started with some simple cell that was just a bunch of blobs and then got to this level. This is presupposed for all of life, this level of complexity and engineering. And yet, the biological community will ask whether this is real. So, next slide.